Hello, and welcome to my code explanation for Intro to Programming. I'm aiming for a distinction level, and we'll be going over my game Jawsome, made entirely in DragonRuby. First off, we've got def tick args. Now, DragonRuby has these little args.states or args.outputs sort of things. These sort of act like arrays, and they can have variables within them, multiple variables within them. Um, they can even act as multi-dimensional arrays. They're very, very cool and very, very useful. This one is seen and is set to intro. Uh, in the program, it will check what scene we're currently in. So it's set in intro, so it's going to render the intro. So this draws all of these output labels onto the screen in the render intro, and then checks if the spacebar is being pressed. So here it is. Here is all of the same stuff that's being rendered. And when you hit space, wrong one. It sets the state to game, which then checks, oh, because this is running every frame, oh, we're in game now, and does game tick args. So we're going to go all the way down to game. It does game tick args. This also initializes the game. So here we've got args. So this is the state of the player. This is all of the player's variables to begin with. And this is all of the game's states to begin with. As you can see, this variable args is basically passed around between all the different defs, I forgot the name, functions or arguments or whatever they're called in Ruby. So game tick. So first off, just sets the player to be args.state.player because a lot of things use the player. Checks if the player's HP is 0, first and foremost. If it is, it'll set the game scene to outro, which will then do the same process as the intro, where it will render and check if you're pressing spacebar. So it will render the game over speed, and we'll check the player's score and display it there. We got a score of 0, so it didn't do anything. So we've initialized the player exists. Next, we've got an eat enemy timer that will constantly tick down, and it's set to 30, which I believe is 5 seconds, because 60 frames in a second, so that's 5. Every 5 seconds, you lose 10 HP. We've got a velocity threshold, so it's going to check the player's current velocity against the player's max speed times the velocity threshold, so 0%. So you have to be above 30% of your current max speed, or else you will slowly lose HP. You're a shark, you keep moving. Player rotation. This will rotate the player sprite plus or minus 5 degrees, depending on left or right. And this, when you've got the key down, so this only checks if the key is currently down or not. So this is a true or false, whereas this is also a true or false, but it's going to constantly update. So it's going to constantly minus or add 5. This just does it once. And it will set the sprite to left or right, so it looks like your character is spinning, is swimming. This sets this uses trigonometry to determine the player's kind of, it's hard to explain. It uses trigonometry to find the player's velocity not velocity, position in relation to its angular velocity. So it's checking. So we've got our angle in radians. So it's going to take the player's rotation and turn it into pi, right? And then it's going to use the player's acceleration as well as as well as the cos and sin of the angle in radians and apply that to sort of a directional x and y axis that is going to be impacted by friction is going to equal the player's velocity and is going to update the player's position. So we are moving directionally. So forward is we are moving forward, and it's going to calculate that forward momentum, that forward movement. So instead of using up, down, left, and right, we're constantly moving forward, and it uses trigonometry to assess that. And it just updates the position. So we've kind of got a directional X and Y. Y and the velocity of the player takes into account for the speed at which you're moving in that angle. Kind of complex to explain. I did need a little bit of help figuring it out, but it's not that hard once you understand it. So friction just kind of taxes the movement. Velocity plays a role in other calculations, but dx and dy handles the movement there. Basically checks the velocity against the max speed and makes sure that it doesn't exceed a certain max speed of the player. Sticks to walls, so if the player is within this state, so the game window is this wide in the x-axis and the y value, it will clamp the player to those arrangements, not arrangements, those predetermined coordinates on the map, and of course we got to minus the width and height. So this dot clamp thing is a thing that exists within inside of DragonRuby automatically and is made to stick sprites to the side of the wall. Speaking of sprites, we're going to draw the player sprite here, and we're going to get onto energy management. So enemies are built upon a timer. So every frame, 120 frames. So 2 seconds, it will spawn an enemy. And that is handled in spawnerEnemy.args. So what it's going to do, it's got 10 tries, or well, 11 to spawn an enemy. I know 10 because it's using, I think 10 tries to spawn an enemy. It will create a new enemy at random, a random coordinate position on the map. It will then check against the array of existing enemies if it collides using this custom function rexCollide here, which basically takes the x values and compares it against width and height and y to figure out if either yes or no it's colliding. So we'll move back up. So is it colliding with any of the existing enemies? No. Is it colliding with the player at that current frame? No. It will spawn an enemy. Either of them are yes, it will increment the attempts, and it will only do it 10 times as to not kind of just flood the game with requests. Where are we at? Draw enemies. So for each enemy, create a solid output. So solids are all shapes that already exist within Ruby. I believe the regular solids is just a square. So we've got our x and y coordinates, our height and width, and the tail end here is color. And it will just create a square at those coordinates with that height and width for every single enemy. Now we need to check if the player has hit an enemy. So it uses rexCollide again of the player and the enemy values for each enemy that exists. If that value returns true, it will add +10 for the player's score, it will add for HP, it'll increase the max speed, and it will delete that enemy because this kind of exists. This is also the index as well. So yeah, it also uses the enemy index and removes it from that multi-dimensional array and sets the eat timer back to 300, so you're full. Draw HUD is a little bit complex. Okay, so our first part of draw HUD is actually split into different parts just so you can read it easier. We have player again. So these labels, these are basically just normal labels that you can see, are drawn to the player's current X and Y positions, and they display the player's HP value and the eat timer, which has been turned from frames into seconds, as well as the player's score in the top right. The velocity bar is really interesting. So the velocity bar basically gets your velocity percentage and creates a fill width, and then draws the bar in relation to the player's current velocity percentage. So the bar itself, so we've got a container here that exists that is the width, the total width of the bar. So imagine, so we've got a line on the outside, and then we've got a rectangle which is slowly filling and expanding. It's slowly getting longer as our velocity reaches its max point. So the borders here is going to represent the 100%, whereas the rectangle that's drawn on the inside is going to constantly expanding. But it expands relational. So it's not expanding in both sides, it's expanding in just the positive kind of X values. So if you imagine the bar at x0, it's always going to be pushing to the positive X values. There is Next is this line which is drawn at the current threshold position. If you remember from above, the threshold was set to 30% of the player's current maximum speed. Yep, 30% of the player's current maximum speed. It's going to draw that on the bar. So it's going to use the bar width to create a threshold position where it's going to draw a red line from the bars, top Y and bottom Y, and draw it in relation to what the current threshold is. So if I wanted to change the threshold in later game aspects, this will automatically do it. And here we just Rex Glide, which I showed you before. So that's the game. It's quite simple. It's supposed to just kind of be an arcadey style game from the era of home arcade systems like the ColecoVision, the Intellivision, and the Atari 2600. Very hard games to complete, not very graphically fidelic, but it's very hard, so you feel like you haven't been ripped off by the seller, and it takes a very long time to complete. I can see this using DragonRuby's. You can publish with HTTPS, so I could see this on Cool Math Games or something or other. Just a time-killing thing. The main aspect of the game is the movement, how it's quite difficult, and you're constantly getting faster, so you've constantly gotta increase your speed, gotta move faster, but it's so hard to move. You're battling against your own movement mechanism, and it's pretty interesting. People who I've shown this game to and given them a try have gotten scores of 200 or more, and seem to be really into it. And I hope you enjoy it as well. Thank you for considering my application.